Good morning. Good morning. Thanks for joining us on this webinar. We've got a really exciting topic for you today. Octopus Deploy is the first and the most mature product for automated deployments on the Microsoft platform, making it easy to orchestrate releases and deploy .NET applications on-premise and in Azure. And whether you are a current user of Octopus Deploy or if you're merely looking forward to DevOps automation, you are going to need a streamlined DevOps architecture for promotion across pre-production and production environments. And you also need to limit who can deploy to production. You need to ensure releases have been tested first and block the promotion of broken releases. And there's a lot of teams that ask some common questions about how to structure deployable application components and how the deployment fits in with other elements in the DevOps pipeline. And in this webinar, I'm going to cover the architecture of a complete DevOps pipeline that integrates Octopus Deploy, how you structure the code in your Git version control system. That can have a profound impact on how easy it is to deploy the code. And key elements of continuous integration also affect the deployment structure. And there's also some rules of thumb that if you follow them, they make the structure of the automated DevOps environment just fall into place really nicely. And if you aren't aware of these rules or if you break them, then you're going to be continually struggling to achieve those no-touch, no-drama software deployments. And so we're going to attempt to get you in and out of here as quick as possible so that you can be on your way to stress-free software deployments using Octopus Deploy. And the baseline stack for this webinar today is .NET Core 3 with Visual Studio 2019 preview, SQL Server, Azure Pipelines, Octopus Deploy, and Azure Cloud. Now, we don't have time to go into every little detail, but we'll point you to a fully functional template where you can really explore all the nuts and bolts. Now, I am Jeffrey Palermo, and I'm your host for this webinar. I'm the Chief Architect of ClearMeasure, and we are a DevOps-centered software engineering company specializing in Microsoft and cloud software. And we have a fantastic audience for this webinar. I'm so pumped at the response and the interest. And it looks like we have a lot of software leaders in today's audience. There's a Q&A window. If anyone wants to ask a question during the content, I'm pretty good at working those in. But I will make my commitment to you that I will not end this webinar until every question has been answered. All right. So thanks so much for your time and for being here. All right. The webinar is organized like this. We're going to move through and just talk about what our shared objectives are, how architecture affects DevOps, the 7 key parts of any DevOps environment, and talk about how Octopus and a build server go together, and then what your next steps should be. Now, some things that you should be aware of and some things you might want to take advantage of. First, the free offer for a electronic copy of my latest book, .NET DevOps for Azure. Now, we've got the preview edition right now. It is showing on Amazon.com. You can pre-order it now. It's being published nationally by A Press. And it'll also be in the bookstore at the Microsoft Ignite conference coming up in November. If you're going to that conference, look for me. I am one of the conference community reporters, so I'll be reporting on all the dev and DevOps topics. It's a massive conference, over 20,000 attendees. We'll be in Orlando the week of November 3rd. Also, if you're going to be at the Ignite conference, then check out my Twitter feed at Jeffrey Palermo for announcements on a Sunday night event, Party with Palermo, that I just published. But you can go to lulu.com here and search for .NET DevOps and find the book if you want the print edition. And you can email me directly for a free ebook version just for attending this webinar. So also at the end of October, the 28th through the 30th of October, I will be teaching another one of my courses, the .NET DevOps Bootcamp, where you will get absolutely immersive hands-on experience putting together a world-class DevOps environment for .NET applications. And so that is seats are extremely limited. We are only accepting 16 people at this particular course. We also schedule private course. If you want your entire staff to be trained, we did a course just about a month ago for one organization completely dedicated to their staff. And for these trainings, I am your trainer. So if you'd like to do that, then take advantage of that bit.ly/.NET DevOps Bootcamp. Okay, now one other resource that you might be interested in, because this is such an important topic, is database DevOps. And just the database is such an important piece of any software package, and there's specific things to think about when putting that into place. Today's webinar, we're going to talk about the overall architecture, but the database fits in, and you have to think about how to deploy the database, what it means to be in version control, what it means to build a database schema and test it and load with test data, and then to automatically migrate the schema changes across environments. And so I did a webinar with Paul Stovall, the CEO and founder of Octopus Deploy, and you can find the recording of that on bit.ly/Octopus Database. And so if you didn't see that past webinar, I invite you to do that. And the agenda is here on the screen, but everybody wants no drama, completely automated deployments, and you can't do that unless you bring your database into the mix. Another resource that might be interesting is the Azure DevOps podcast. One of the shows that's out literally today, this week, is a engineering lead, Jared Parsons, an engineering lead on Microsoft's C# language and compiler team, and how that team puts together their DevOps environment, soup to nuts. So fascinating. So there's a lot of success stories. Check out that podcast, www.azuredevops.show, or any of your podcast directories. All right, so let's get into what we're trying to do here. What are our goals here? Before we're really talking about the architecture of an Octopus Deploy-based DevOps pipeline, let's discuss our objectives. And there's three things that we need here. Three things we need to think about. We need to think about the architecture of the software. We need to think about the organization that is using this. And then we need to think about what our budget is and what our schedule is and what are the targets that we're operating under, because that's going to influence everything. Now, as a judge from the list of attendees, you are leaders. And with the right strategy, things fall into place nicely. With the wrong strategy, no level of execution can make it great. And if you think about software architecture is a special type of strategy. It is making choices on what to do and making choices on what not to do. And of course, it has to be executed well, but the strategy, that's your plan. It's not a goal. It's not a target. It is your plan and the decisions that you are making to achieve your goals, to achieve your target. It gives your team, your organization direction. And there's three types of architecture. These are the three types right here on the screen: the design of the system, the design of the organization that builds the system, and the meeting of budget and schedule targets. So DevOps helps give us a model to ensure that we identify all of the needed architectural elements. Now, if you haven't read the Phoenix Project or the DevOps Handbook, then I recommend you read them. But if you're familiar with the Agile Manifesto and the Agile software development movement that started way back in 2001, there was a set of guiding values and principles. Same thing with the DevOps movement. There are three ways. They are the three guiding principles. And the first is flow, the second is feedback, and the third is learning. And all of them need to be continuous. And so flow is the automation and smooth flowing of an idea for a change all the way into production, and not have big batching or big bang releases, but a continuous, steady flow of changes. Feedback is all of the quality control techniques and all of the information that flows to give you a sense that you are doing the right thing, that you are not just flowing defects through to production quicker, but flowing through valuable features. And so you need feedback all along the way. And then learning is baking into your DevOps environment the capability to give you the knowledge to know that the changes that you are making and giving to your customers are the right changes and not the wrong ones. Okay, so for a DevOps environment, there are some inputs and outputs. It can be easy to think of architecture as the structure of an application itself, and it is. But the DevOps environment is a system. It is a computer system. It is a system with inputs and outputs. Design this whole system, not just the .NET application that this system surrounds and supports. And so with any type of system, you have input of feature requests, and specifically think about the DevOps pipeline. In the beginning, there is a request for some type of change, feature, or learning about how the software is being used. And then you do a whole bunch of stuff. You change some code, you produce a new build, you validate it, you version it, you deploy it, you get it in the hands of the customers. And now the output is a new feature that's in use, the change that's made, or better telemetry so that you can learn more about how things are going, how your customers are using it. Now, for every, as much as we talk about an automated DevOps pipeline, we have a complete model for DevOps-centered software engineering. And we call it Onion DevOps Architecture because, kind of looks like an onion. And way back in 2008, 2009, I wrote about an application architecture called Onion Architecture, about how to structure a Visual Studio application and manage dependencies. If you're interested in that, just search for Onion Architecture. It's probably the first or second result in the search engine. And it's on my website at jeffreypalermo.com. And so there are additional layers, additional architectural layers when thinking about a DevOps capability. And we won't go deep into this, but they're the practices that you're going to use, how you're going to remove defects, what the workflow your team is going to use, the architectural blueprints, how you illustrate the structure of what you're building and how you're building it, and then how you operate cloud operations. And the cycle, which you want to be really quick and ever increasing, is plan, code, integrate, package, release, operate, learn. You want to spin that cycle around the hub, around that automated DevOps pipeline faster and faster and faster. So for each of these layers, starting with the center on out, you need a sound strategy. You need to execute that with discipline, and you need objective measures to give you the telemetry and the feedback to know things are going well. Now, let's dive into the center of the model, which is the automated DevOps pipeline, which is the automation. This is where Octopus Deploy lives, along with your build server. Now, what you're seeing on the screen is a highly shrunken technical blueprint for the structure and flow of a pipeline implemented with Azure DevOps Services and Octopus Deploy, with continuous integration and a 3-tier deployment pipeline. And I want each of you to have this. So Rain is posting a download link in the chat, and this is just the top third of this architectural poster. And you can print it out at your local print shop. This is the overall architecture for an automated DevOps pipeline. It shows where the key 7 steps fit in. And we'll go through each of them, and I'm going to talk about how each of them must be done right in order to have success with an Octopus Deploy implementation. And the full PDF that you'll receive, high resolution, you can print at 2 feet by 3 feet. That's Architecture D paper. And before we move on, this is just what the whole thing looks like. I know you can't read any of the text at this size. It's rather large. So go ahead and request that. All right. Let's see. As we move on to the 7 key elements, we'll dive through the pre-code design process, the things you need to do even before people set eyes on the keyboard, and how to structure source control, what key things need to be in the build process, how to do your full system testing. Now, we're not talking about unit testing here. We're talking about full system testing, testing that occurs after the first deployment. Then we'll talk about how to execute user experience testing, production release, and how to observe what the system is doing, telemetry observation. Because those are the key 7 elements of a proper DevOps environment. You have to think about all 7 of these, or else you're going to have your gaps. All right, so let's talk about the pre-code design process, which really is a process. And right here we have 12 stages from coming up with an idea to actually operating and supporting a software change or a new software feature out in the wild. Now, this has 12 steps. Most teams that we encounter these days are using a Kanban board of some sort. They're tracking their work on a virtual board. Some teams that are 100% co-located are using sticky notes, which had been really popular in the past. But so many people are going to electronic systems for tracking work these days that pretty much emulate a series of columns. And you move a piece of work on a square, virtual card over from the left to the right. So each one of these steps, each one of these 12 steps, think of it as a column on your board. All right. Now, there are 4 things that you need to do before anybody can write some new code or change existing code. And they are the top 4 elements. And they can go really fast, or they can take a lot of time. They can be done by the same person, or they can be done by 4 separate people or groups of people. But it's important that by the time your developers get a work item or a card or an issue to work on, all 4 of these decisions have been made and are part of that work so that they have that information. Otherwise, they're just going to be guessing at what to do. So let's go over them one by one. And yes, these 4 should be on your board as independent columns. The first one is conceptual definition. What the heck is this change? What the heck is this feature? Now, let's take a really common type of feature, which is some new screen that is a part of the application. Some screen needs to show some data, do something, take some input, have some buttons, allow the user to do something, the screen. All right, so what the heck is the goal? What is the user trying to accomplish? And just defining the concept, okay? Next, after that is well understood, after the goals are established, now we have to establish what the user's experience is going to be using it. Is it a 1 screen, just do it all, click a button, you're done? Is it a 3-screen wizard process? And what are the wireframes? What are the screens going to look like? What are the data fields and the order of the data fields and the types of them on the screen? We need some wireframes. So we need to determine what the user's experience is going to be like. Are they going to be walking around on their phone with a small screen? Is it going to be a desktop full-size screen? Is it going to be speaking to Alexa and a voice recognized AI user input telling it what to do? What is the user's experience? Now, once we've established that, then we need to make whatever key technical decisions are necessary. Are we going to use any libraries, build versus buy? Or are we going to use any design patterns? Are we going to use what frameworks are going to be at play? If this is a new feature and we've been working on the application for a while, does the inclusion of this feature cause me to have to add any libraries or any NuGet packages? Those technical decisions need to be made and not left to assumptions or to whichever developer happens to be assigned this feature. Then, after the technical decisions have been made, and by the way, that includes changes to data models, that is part of the technical design. Then the fourth type of design is acceptance criteria or test design. And that is with the full understanding of what this does, how the user is going to use it, and what the technical decisions, constraints are. Let's determine the scenarios of how we're going to test this now that we can imagine in our heads what this is going to look like once it is actually implemented. And let's design how we're going to test and validate it. And if you're using Scrum calls for clear acceptance criteria of a product backlog item and a simple bullet list of how someone would manually verify something. That is the perfect format for acceptance criteria. Now, you take that, and all of that information is available in the work item or story card, then a developer is going to be well positioned to write the code and do it right the first time. And so all of those things are super important to get your DevOps process going right from the get-go. And that's the pre-code design process. Now, formatted onto a Kanban board, this is kind of what it looks like, 4 different columns. And it's very common to have a feature that is conceptually defined and the user experience is designed. And then in the technical design, realize, you know what? This really should be implemented in a few different pieces. So let me decompose this feature into a handful of user stories or a handful of smaller work items that can be independently implemented. And so decomposition is it happens there quite often. All right, so that's before you even talk about code, you need to arm yourself with these 4 different types of decisions. By the way, I don't care what you call these names. There's nothing magical about the title, but there are 4 different concepts, types of decisions that you have to decide. And if you don't, then your developers are going to have to make assumptions, and you leave risk in the system of them just creating rework for themselves. All right, let's dive into the code. Now, by the way, we're talking about how to do automated deployments, but we're talking about the things that really affect how to do an automated deployment. And if you miss them upstream, they're going to cause problems downstream. And so when we talk about, if I go back, when I talk about test design, that flows right into full system testing, which is the type of automated testing that happens after the first deployment. And we are deploying our application and the automated tests that are developed from these design tests with Octopus Deploy in order to execute them. And so they have to be defined here. If you leave them to be defined after the code is developed, then they're a lot less potent. You lose a lot of information and your quality suffers. So now let's talk about the version control structure. There are some rules that you can follow that all of the products out there in the industry, build servers, static analyzers, testing frameworks, deployment software, all of them kind of assume certain things about how the source code is structured. And if you follow those norms, then things are going to fall into place for you. If you don't follow those norms, then you're going to have to write a lot more PowerShell script or compensate in order to adapt it. Okay? Now, let's talk about the nature of a software system. Software systems can be large and complex. Now, we've all heard of the monolithic software system where the entire system was a single application that was a single code base, all right? And I think we as an industry have realized, you know what? Big code bases are just hard to manage. Let's try to find a way to break up systems into multiple independent applications. And I'm not going to use buzzwords like microservices or service-oriented architecture or anything. I'm just going to use the concept of generally we as an industry have said, we've gone too large. Large code bases are hard to manage. Let's try to break them up in some way, right? Lots of people are asking that same question. So a software system is segmented into many versioned software applications. Now, let me give you an example of a versioned software application. One Visual Studio solution, it can have, 1 or 2 web applications. It can have a scheduled task. It can have a Windows service, and it can have a database schema that it owns. And that is a single versioned application. It is built together. It all has the same version number, and it is deployed at the same cadence. Okay. Now, if the Windows service starts getting deployed on a different cadence, and it starts changing more independently, and it starts having its own life cycle and different forces that cause it to change, then it probably is trying to tell you that architecturally you should segment it out and declare it to be its own application and yank it out of that code base and put it into a separate code base and then have it integrate based on well-known APIs. So a software system can be broken up into multiple applications. Each of the applications needs to have its own dedicated Git repository. A application resides in one version control repository. And one version control repository, one Git repository, has one version software application. That is one Visual Studio solution. Okay. Now, a team can have many Git repositories and develop many applications, but whatever's in a Git repository can only be owned by one team. It's really, really hard. And you see some examples of massive companies of them kind of breaking some of these rules, but they do a lot of effort to compensate for breaking these rules as well. For most application developers in your company's software department, these are the rules. And if you follow these rules, everything will just fall into place nicely for you. All right. Now, and once you have one software application, it's in one Git repository, then you have one DevOps pipeline for that particular application. And that pipeline has one build, and then it has a series of sequenced deployments. Now, for software systems that are comprised of, dozens of applications, well, the software system itself will then need to have its own DevOps pipeline where the dependencies are the builds of all the different applications. So when you have a large complex software system that's been decomposed, then you end up with a two-tier DevOps structure where each individual application, each individual Git repository with its accompanying Visual Studio solution has its own DevOps pipeline, produces its release candidates, and then the software system itself has a pipeline that has a deployment and configuration pipeline that takes all of the applications together and gets them working properly together in an environment. That's a topic for another day. Now, let's jump into the build. There are some key things that you want in your build. Every build needs them. Now, every build is going to be a little bit different, but every build needs some of these concepts. And so the first thing is you want to clean out other artifacts of past builds. You're going to be using a build story, even if you're using Azure DevOps Services, which is my favorite, which is great. You need to be using a private build agent, which is going to have some artifacts from previous builds, because you're just not going to clean out everything. You need to cache some things. You don't want to reclone every time or do a completely fresh NuGet restore for every build. That's just going to waste a lot of time. But all of the past build artifacts, you want to clean those. You want to get rid of your temp directories. Then you want to stamp everything with a version number. You want to use the common assembly info pattern where you are pushing the build version into that assembly info file that's used in all the projects in the application, so all of the DLLs get stamped with the right version number. Your JavaScript assets, your database schema, everything needs your version number, and oftentimes that needs to happen pre-compilation. Then you need to create this application's data store, whether it's a SQL Server database, document database, or just a series of file folders. If you import or export files, you need to set up the data stores for this application so that you can do some basic validations during the build process. Then we're going to transform our source code into executable code. That's the compilation process. Then we need to run whatever tests can fit within a 10-minute build time. Oftentimes, all of your unit tests can fit. These are tests that do not call out of process. And then your component level integration tests, tests that do call out of process between components only of this application. So if you have code that calls out and does a query through Entity Framework to SQL Server, that's perfect for running in your build because it is between two components that are going to be running in two separate processes, but that are part of this same application. In our build process, we don't want to be doing anything that requires integration with a separate application. That happens later on in the pipeline. Once those tests pass, then you want to have static code analysis, whether it's one pass with Roslyn, multiple rule sets, ReSharper, Independ, whatever tool, SonarQube. There's a lot of great static analyzers. Your JavaScript linting tools, drop them in the build process. You want to have static code analysis. There are 3 quality control pillars that you must have, or your quality is never going to get what you want it to be. The first one is static analysis. The second one is testing. The third is formal inspections. Testing, the automated testing, you want to pack those in. We'll talk about the formal testing later. After the static code analysis runs, you want to publish your test results. Then you want to package up the application components. And if you have a web application, that's a NuGet package. If you have a database, that's a NuGet package. If you have a Windows service, that's a NuGet package. Anything that runs in an independent process once deployed is a NuGet package. Don't try to jam everything into a single NuGet package, because then you're just going to leave it down the line in Octopus Deploy and make it more complicated to grab it and then deploy all the different pieces. You need to take every independently deployed process that's a part of this application and make a versioned, named NuGet package release candidate out of it. And then you publish it to Azure Artifacts. So that is the build stage. Now, before we go on to actual deployment, let's talk a little bit about release candidate packaging. You need to make some decisions about your runtime environment. Is it still on physical servers or virtual servers at an on-premise data center, or is it all the way to the right in Azure App Services where you don't even have access to those VMs? And I understand if you have some hosted VMs at a hosting provider, or you're using VMs at Rackspace, or if you're already on .NET Core and you're targeting Linux and you're making use of some containers, or all the way with Platform as a Service. Now, the further to the right, the less you have to maintain personally. The further to the left, the more you have to maintain personally. Now, the correlator on the far left, you have absolute control, but you also have absolute responsibility. On the far right, you have less to maintain, less responsibility, but then as a corollary, you have less absolute control. Oftentimes, for most business applications, pushing things as far to the right as possible is the way to go. Now, there are some caveats because you don't have control. Here's a really common scenario. If you have a screen in your application that uses a barcode font in order to print barcodes on a screen that will be, say, printed on shipping label or otherwise need to be available for scanning a barcode scanner, well, that's a custom font. You cannot install custom fonts on Azure App Services. So if your application requires that and you can't use a built-in font, you absolutely need a custom font and need to install it, then guess what? You're hosed when it comes to Azure App Services. You can't install custom font. So you're going to need to back up to something where you can install a font. Now, if it's .NET Core, you can use one of the container options. If it's .NET Framework, can't use containers yet, you have to go back to an Azure VM. So that's the juxtaposition with control versus what you have to maintain personally. Now, let's say that we are going to use Azure App Services. Let's map a particular application over and see what that looks like in our packaging. So if we have ASP.NET UI and we're going to package it up for Azure App Services, well, we've determined that, and there's some files, some code configuration that's not environment specific, but it is runtime topology specific, and it needs to be in the source code, just the way Visual Studio works. And so we're going to designate that the web application is going to have a NuGet package targeting Azure App Service Web. Then an offline job, we're going to package that up and target Azure Functions running an app service. Then we have a SQL Server database schema. We're going to package that up along with the migration scripts and the tool for running those migration scripts, probably DB up from Octopus Deploy itself. And we're going to target Azure SQL. That's going to be a NuGet package. Then we have an in-unit test suite that has our full system acceptance tests. These were the tests that were defined in the pre-code design process. Our acceptance criteria and the definition of done for a particular user story for a developer with hands on the keyboard is turning that designed acceptance test into a full system test that probably runs with in-unit or X-unit. And if it's a web application, uses Selenium to open up a browser and actually walk through those series of actions to make sure that the screen does what it's supposed to do. That test suite needs to be its own NuGet package, and it's likely going to be deployed on a Azure DevOps Services hosted agent in order to execute. Remember, Octopus Deploy is not a build server, so therefore it does not run test suites. You need to run test suites on your build server. But Octopus Deploy will deploy it to your agent as a target, okay? So let's talk about the destination for packaging. Octopus Deploy has a built-in NuGet server. You can deploy you can push all of your NuGet packages to that NuGet server. Caveat: that is not a complete NuGet implementation. It is only accessible by Octopus Deploy itself. It's not accessible by any third-party NuGet clients. So you can either take your acceptance tests package, release candidate, and push it to Azure Artifacts and the rest of them to Octopus Deploy, or you can push all of your NuGet packages to Azure Artifacts and then have Octopus Deploy grab the application components that it is deploying and push them out where they need to go. All right. Now, let's talk about actual Octopus Deploy and build server integration. This is the post-build Octopus Deploy integration. Now, you can see that this is part of our architectural poster. I'm showing you 3 environments. You're never going to have fewer than 3 environments because there are 3 environment types and you need at least one of each. So everybody knows production. And if you are running the system and you have one production environment, that's great. You might run a different production environment for each individual customer. That's fine too. You need at least one production environment. Back up from that, and you have your manual test environment. I like to call it UAT. You have your manual test environment, and you can have as many of these as you want as well. There's a lot of common names that have cropped up over time. UAT, staging, test, QA. There's all kinds of, even dev sometimes is a manual test environment, but you need at least one. Now, back up a little bit more, and there's a type of environment that a lot of people haven't adopted yet. People who are still just adopting test-driven development, I like to call it the test-driven development environment. It is a automation-only environment, no humans allowed. And it is for the purpose of taking a build, deploying it to an environment, running the acceptance test suites, or running any full system test suite and validating it, and then throwing the environment away. That makes sure that by the time your software gets to any of the manual test environments, you're not going to waste the time of a human with a build that just blows up right away. And I guarantee every single one of you on this webinar, sometime in your career, has had a pre-production software deployment where a new build was deployed to somebody and say, hey, go check it out. And they pull it up and the initial screen just blows up with a big error. And they're saying, hey, it's erroring out. And you look at it, it's like, oh, shoot, man, that was embarrassing. Why didn't we catch that before? Because there was literally no validation that the new software build was even compatible to be deployed to an environment and start up properly. Okay, so that's what this first line environment does for you. At a minimum, it makes sure that the new build will actually start up. And then on top of that, we can run all kinds of full system tests. Now, the acceptance tests that are translated into full system tests, those are your functional full system tests. Now, again, if it's a web application, you're going to be using Selenium and you're going to be opening up browsers and typing in text boxes and clicking on buttons and literally driving it like a robot tester. But there's other types of automated test suites where you can have multiple of these TDD environments. And for instance, automated security penetration testing, automated performance testing and timing capturing, automated Section 508 screen reader compatibility testing to make sure that that it's ADA compliant. You can have all kinds of test suites that need and should happen before you declare a build ready for an actual human to give it the time of day. All right. Now, there are 2 different strategies for integrating Octopus Deploy. One is the fire and forget handoff, and the other is orchestrated. Now, what I'm illustrating for you here on this screen is the orchestrated strategy, which most of the time I prefer for individual applications. For the second tier DevOps pipeline for multi-application systems, a fire and forget handoff is appropriate for that type of pipeline, but that's for a different topic for complex multi-application systems or systems that have been decomposed and use a microservices approach. But let's stick just for the one case where you have a single application. Again, our example is a web application, offline job of some sort, and a SQL Server database. That kind of general architecture is so prevalent everywhere. So I think most of you are familiar with that shape of an application. So what we're going to do is we're going to have our build server orchestrate the sequence of environments. And now, specifically, Octopus Deploy has a concept of a life cycle. We are going to defer the life cycle rules for this type of pipeline to the build server. Now, we do this because the build server needs to run tests, and so that we in larger organizations, we can have stakeholders that have approval access while being able to keep our Octopus Deploy user list very small. Now, this is important. Octopus Deploy and the tentacles are going to be installed on all of our environments and our production environments. So control over those and control of the environment and control over changes to the deployment sequence is absolutely key. And so we want to keep the user list as small as possible. And so when we set up the deployments and the deployment logic should not have to change very often. Things are changing because the source code is changing. Okay, and even if we use routines in the deploy.ps1 file or post-deploy.ps1 file that Octopus Deploy can execute immediately after deploying what's in a NuGet package, those are stored in source control. So if we need to change something, those are change controlled, reviewed before they execute on production. So what happens here is, let's use Azure DevOps Services for our build server, and we use Azure Pipelines for modeling the sequence of environments, and we delegate to Octopus Deploy for the heavy lifting of the deployment. Then control can come back to Azure DevOps or Azure Pipelines so that it can execute a test automation suite. All right, that's why we do it, is so that we can execute tests after we do the deployment. All right, remember, Octopus Deploy is not a build server. Now, this is what it looks like in Azure Pipelines. This is not the brand new YAML edition because that's still getting adoption. But remember, the two integration strategies, this is the orchestrated strategy. Now, let me just talk about some pros and cons. The fire and forget handoff method, where you just tell Octopus Deploy, hey, create the release, and then to deploy to downstream environments, you use Octopus Deploy, not Azure Pipelines. We have segmented DevOps pipeline logs in those cases. Some of the logs are in our build server, and some of the logs are in Octopus Deploy. All right. And approvers for deployment to production, they will have to have Octopus Deploy accounts. Now, the orchestrated strategy has some advantages in that front. All of the logs will go in your build server because Octopus Deploy has a feature where it streams every bit of deployment logs back to the build server that's calling. And also, the approvers can have stakeholder accounts and have no Octopus Deploy access, and then can click a button in Azure Pipelines to authorize deployment to production. That's really awesome to be able to give one of your executives access to the button, but not have to give them technical access to Octopus Deploy, because Azure Pipelines supports stakeholder accounts really easily, and it's natively integrated with other things that they're using. Also, remember, you want to run tests after a deployment. Some of the Octopus Deploy scenarios don't have any parallel in Azure Pipeline. So if you have some complex channel configurations or life cycles, or if you make dynamic use of tenants, tenants are not dynamic in Azure Pipelines, and so the orchestrated model can have some limitations there. The normal day-to-day cases work fine, but again, if you're dynamically provisioning and configuring environments in parallel using tenants in Octopus Deploy, then you'll likely need to use the fire and forget handoff method instead of orchestrated. But these are the two strategies for integrating Octopus Deploy with a build server. Now, this is what it looks like to integrate it. You'll create the Octopus release. Now, we want to make sure that we're creating the release and giving it a specific release number. Okay, we don't want to through this integration let Octopus Deploy just deploy the latest version. We want to deploy specific versions because that makes us resilient to branching, and that makes us resilient to be able to redeploy previous versions. Okay, so this is the TDD environment. We are creating and deploying, creating the release in Octopus Deploy, and once that finishes, control returns to Azure Azure Pipelines so that we can download the test package, then push in connection strings and configure it, and then run those acceptance tests. Now, you'll look at the additional octo.exe arguments for Octopus Deploy, and this is for variable management. Variables are so important, and we need to think about who owns a variable. It's a piece of data. For instance, let's say the connection string or just some other setting. Should Octopus Deploy own that setting, or is it a setting that's actually owned by the build configuration and possibly inherited by the release configuration, whereby you would say, you know what, Azure Pipeline should own that variable. Either way, it's a decision that you have to make. Now, for the variables that Azure Pipelines owns, you should not declare them again or put the values again in Octopus Deploy. You just pass them on through. And so this is where you add additional command line arguments to pass in additional variables straight to Octopus Deploy so that Azure Pipelines can own the value, and then Octopus Deploy can just accept that value. Okay. Now, for subsequent deployments, there is a separate Octopus Deploy task called deploy release. There's two. One's called deploy, one's called promote. I don't like using promote because in the orchestrated scenario, it lets Octopus Deploy decide which one to promote. And it's going to decide the latest release that's deployed to the environment that precedes it in the lifecycle configuration. I much prefer for the integration to explicitly deploy a named version because we know what version it is and we're passing it in. And that gives us a lot of control to deploy and redeploy and open up more scenarios. All right. So again, for review, strategically decide which system is going to own the responsibility for deciding what version to deploy to the environment. And I often like Azure Pipelines to own that decision and pass it through. All right. All right, coming back to the variables that we pass in. This is the edit variable dialog in Octopus Deploy, and there is a checkbox, and this is where it is called prompt for value. If you are passing a variable from your build server into Octopus Deploy and you don't have prompt for value checked, Octopus Deploy is not going to be looking for incoming variables. It is going to say, oh, well, that's a blank value, and it's not going to respect it. And so you need to make sure to check this box so that it pays attention to the value coming in from those arguments. All right, a little trick there. All right, and this is what the Octopus Deploy process looks like. And notice that human approval is often shown, it's in the docs, and it's available. Now, if you are using the orchestrated strategy for integration, you don't want to use human approval. You can see it's disabled for all the environments, but you do not want this to be here unless you're using the fire and forget handoff approach where the approvals and the lifecycle logic is enforced by Octopus Deploy. If you're using the orchestration method for normal applications, do your approvals in Azure Pipelines, not Octopus Deploy. Then look at number 2, application insights, annotate release. You absolutely want to push telemetry for the fact that you are deploying to a particular environment. And for .NET applications, application insights is fantastic at instrumenting your application and sucking in all of the logs of all types, not just what the application is doing, what the user is doing, but also what your pipeline is doing and when you're deploying a particular release, okay? Now, once you've said, hey, I'm deploying a particular release, now we want to, in this case, we're deploying a database schema and a web application. Those are the two components. We want to grab the NuGet package that represents our database migration, and we want to create on the TDD environment, we're going to be creating a database from scratch. On downstream environments, UAT and production, we're just going to be modifying and migrating those existing databases. But we want to do the database migration, and then we want to deploy the ASP.NET UI. And so number 3 grabs a NuGet package for database. Number 4 grabs a NuGet package for the web application and executes those. All right. Let's talk about variable architecture a little bit more deeply. A variable is a piece of data. We've already talked about the need to determine who owns it. And let's dive in deeper on that. So ask yourself that question. Is the system of record the build system or the deploy system, or some external system where perhaps the data needs to be pulled in? For customer configured environments, sometimes there's a CRM or some other, it could even be an Excel spreadsheet somewhere that is the system of record for the values. We don't want to duplicate things. We want to use the DRY principle. Don't repeat yourself, which is part of the solid principles. If you don't create a strategy for configuration management, you're rolling the dice on a management nightmare in short order. Every system has configuration management needs, and you must design it. Remember, design doesn't just happen. It has to be intentional. You are going to, in any complex system, you are going to have lots and lots and lots of variables. You need to intentionally create a topology and make sure that you're not duplicating values. Octopus Deploy allows dynamically building variables from a combination of previous variables. If you have a common drive letter where you're deploying things to the N drive, if you're deploying to VMs, or you're deploying things to the D drive or the E drive, and that's just kind of where you put things. And you see yourself with, there's several variables, and it's D/some path, D/some path. Well, guess what? You're repeating the D drive. Carve off that D drive into its own variable, and then include that variable in another variable and build it up. Make sure that you don't repeat values or any portion, any predictable portion of a value. All right, decompose those variables just like you would normalize a database schema, and just like you would deduplicate source code and say, oh, look, I copy and paste that source code. Let me factor that off into a function. Same thing with variables, okay? And it's a lot of effort. I know it is. All right, let's talk about defect removal and full system testing. So what we see on the screen here is the pull request process. And this is the perfect place for that third part of the quality triumvirate, which is a formal inspection. So remember, going back to our acceptance criteria, we specify test scenarios, all right? Now we change code, then we run the private build on the local workstation, then we do a git, commit, and push. We're on a feature branch. Everybody's doing branching these days, which is great. As an aside, if you've heard of trunk-based development, most people are doing trunk-based development. If you go to trunkbaseddevelopment.com, then you will see the pattern described. And it is described as doing every single change on a branch and making sure they're short-lived. So talk about a terrible name, trunk-based development, when every change, every bit of development happens on a branch and no development happens on trunk or master. So it is what it is. But the predominant branching strategy that people are using today is you branch for everything, you do your changes on a branch, and you get that branch merged in as fast as possible. You don't want to leave those branches open for long. So on a branch, you're doing a private build, you're doing a git, commit, and push. A continuous integration build happens on your branch, testing, static analysis. Then we deploy. We deploy the product of that branch to a TDD environment. And with infrastructure as code, we can provision that TDD environment dynamically whenever we want to, and run the build, run that test, and then throw it away. So we can do it on every branch. After we run our automated acceptance tests, then we know that we're ready to submit our pull request. So we submit the pull request, and then somebody who reviews the changes that I'm requesting to be pulled into master, there needs to be a formal inspection. What do I mean by formal inspection? I mean a checklist. And for your team, you need a pull request checklist. And that is, what are the things that are going to be checked so that the person who's the reviewer is essentially raising their right hand and say, on my honor, on the stake of my reputation, I am verifying that I validated the changes in this branch for every one of the criteria that is on our checklist. And when I hit the approve button on that pull request, that whole checklist has come through. That is proven by research to find and squeeze out all kinds of defects. So make sure that your team has a checklist for your pull requests, and make it an inspection, not just oh, looks like you put the braces on the right line, approve. That doesn't make a hill of beans difference for the software stability. Now, it needs to be one item of your checklist conforms to coding standards. All right, one item on your checklist, but you need to have other items on your checklist, and that's for you and your team to decide. So if we look back at our Kanban board of this cycle, where the cycle happens, we specify the test scenarios in the test design column. We develop the code for the feature and the full system test scenarios. We write the code at the same time, and then the functional validation is we deploy to a environment, we run the full system tests, and then after that's done, then we can submit our pull request. And then after we submit the pull request, now it's ready for user validation. Okay. Now the next, I want to dive in a little bit on Azure Pipelines and what it can do for your full system tests. So whether you're using InUnit or XUnit, all of them support attachments. When you're running full system tests and you're pulling up a browser and clicking through, I like to take screenshots. And here we can see 6 different tests, and we can see a screenshot. Let's blow it up a little bit. Let's expand it. We can see on the right, every bit of this is the inside of a web browser. It just captures the document element. So you can see a title and some navigation on top. You can see this is a form with some text boxes and a button. And so there's 3 steps, and we are going to actually type in text boxes automatically and hit save. Now, when one of these tests fails, it really, really helps to be able to see what it looked like, and you can repro and validate so much quicker. And guess what? These attachments are free. Disk space is practically free. So just take your screen grabs for every one and just leave them there. It helps so much. Okay, let's move on more to downstream deployments for UAT in production. Now, here's a table for common things that you want to do across all of your environments. We want to actually migrate the database. We want to deploy the application. After we deploy the application, we need to run a built-in health check. We need to call some endpoint that exists only for the purpose of saying, hey, the whole application's running. It doesn't give us a hill of beans value just to say that the web application is online if the connection string is bad and I can't reach the database, because then when the screen calls out to the database, guess what? It's going to blow up. So our built-in health check, it can be an HTTP endpoint that just returns HTTP 200. It can be a web API designed to be called with Postman or an HTTP client, but it needs to call every application dependency so that when it returns success, it's not just saying that the website is operational. It's saying that every deployed component of the application is online connected and is ready for use. All right. Then we want to load static data into the environment that may be changed. We want to load test data in the TDD environment. And you see the TDD environment, we do a lot more than in the downstream environments. One of the rules with automated deployments is that for everything we do in the production environment, it needs to be done in an automated way at least once in an environment prior to it. Nothing should ever be done on the production environment for the first time. All right, let's wrap up here because I know we're going long. Telemetry is our last item. We want to funnel everything to application insights so it can be queried together. We don't want to have to go on the environments. We want to have all of the telemetry in one place so that we can query it. There are 3 types of telemetry: logs, metrics, events. Logs you're familiar with. Metrics and events are kind of like our data warehouse elements, dimensions, and facts. The Kimball method of data warehousing. Metrics are numbers. They can be aggregated together. Events are strings. They can be grouped together so that we can select count, group by, select count where event equals login successful, group by day. And then we can see how many logins on a particular day. All right, we need to push that through. Now, application insights give us all kinds of stuff for free just by attaching it. This is one of the markers. And remember how we're tagging when we're deploying? This is a deployment marker. this tells us we deployed and we have a little bit of traffic afterwards. So if something goes really wrong, we know exactly when we deployed what version of the application. If we click on that little marker in Azure Application Insights, we see exactly who deployed the application and gives us a wealth of information. So those are the 7 key elements of a DevOps environment. And all 7 are really important. We've done this for so many clients. We love enabling your team to be self-sufficient and a new capability. We have some stories on our websites, and our goal is for your team to gain a new capability and for you to implement Octopus Deploy in the right way. So if we can help reach out, we want you to be able to do this. We don't want to just come and do it for you. We want to come in and do it initially, perhaps for one application, so that you can see the pattern and then you can carry it forward. And also, we train this. We just did Octopus Deploy specific training class a little while back, and our .NET DevOps Bootcamp is coming up. And so there's a myriad of ways we can help. This is my direct contact information, and I'll leave this up for a little bit. I think I've answered all the questions in line, but feel free to reach out to me directly and in person. I'd love to chat about your particular projects and love to be able to help, and hope that this information was very useful. And thank you so much for your time. I know it's valuable, and I wish you well in leading your DevOps initiatives and Octopus Deploy implementation. Have a great day.